Thank you for reminding me. I had forgotten to start recording. Thank you. Okay. Friedman's theory was that universe looks similar in all directions, and this is true wherever you go. And then he told universe is expanding, and it can either contract after some time because of gravity, or it can defy gravity and continuously expand. And this gentleman called Lemaitre, a Welchian priest, he came up with another theory almost in similar time duration, similar timelines, that if universe is expanding, that should be true based on general relativity. That means before some time should have been smaller, before some time further smaller, before some time further smaller, which means at a much earlier time, it should have been infinitely smaller. Yeah, you have heard of this theory? Have you?
Big Bang Theory.
Yeah, so this is what famously we call as Big Bang theory, right? So this is actually this gentleman called Lemaitre proposed it. But then there was an interesting thing when he published this article. It was in a very lesser known journal. Not many people knew about it. At the similar time, in another part of the world, a gentleman called Hubble, he developed a very advanced telescope, and with that he started observing galaxies, other stars, other things, and he started measuring, observing the light which are coming from different galaxies. Because the only way for you to study about distant objects, distant stars, and distant galaxies are based on the light which comes from them, because we can't go there. See, if it is 500 light years away, 5,000 light years away, 1 million light years away, how can you go and come? So what you do is, we try to measure the intensity of light which reaches us. Intensity of light which reaches us. Okay? And then we have some idea about the, when light travels, if you have some brightness, when it travels in space for long kilometers, long distance, after some point it will lose some energy, and then it will become dim. It will lose some of its intensity. So by measuring the intensity of light which you get, okay, and if you have some idea about the original intensity of light in that star or galaxy whichever you are talking about, you can measure how much distance the light is traveling. So almost all our idea about the distance of objects in space are based on analysis of light. So this gentleman called Hubble, he started analyzing the distances of different galaxies, and he started marking them. And then he did a very painful job. Then what happens is, each time he was observing that light, he noticed something particular. So what he noticed was that the light is becoming more and more reddish, more and more reddish. So that means you observe a light from a galaxy, it is having some color. After some time, after a few years, after some time, it is getting slowly to the red side, like with geo, right? The color spectrum, you have on one side the violet and on the other side the red, and it's slowly going to the red side. Okay. So what is Rishikesh asking? What is intensity of light from the starting of light? It depends on it depends on the temperature of that star. What is the intensity of light is depending on the temperature of the star. Okay, I'll come to that. Okay. So now this Hubble observed that this is becoming more and more reddish. Okay. So now, when something becomes more and more reddish, it has some reason. It has some reason. There is pure science into that. Okay, we will come to that. Why it is becoming more reddish? Actually, if you observe the light from a specific star, and after some time, if it is becoming more bluish, that means that object or star is coming closer to us. And if the light is becoming more reddish, that becomes means it is going away from us. I will tell the science of that now. Okay. So now that's what we call as red shift. That is called red shift. Okay. So when you see the three things which happened. One, Friedman puts together a theory based on general relativity, which Einstein himself refused to look at the implication of his own theory. But Friedman caught that by telling if general relativity is true, that means the earth, the time, space, that fabric should be a war, which means at some point, because of some collisions and some changes in mass of the objects in the universe, the gravitational force should attract things, and the universe should become like a cloud, a matter which is all attracting each other. So he told that if this is not happening, that means universe is expanding. That was just a hypothesis. Then this gentleman called Lemaitre, he came up with another postulate, another theory that a universe is expanding. Universe is expanding based on general relativity. If universe is of some size today, after some time its size should be bigger. After some time its size should be bigger, which means before some time size should have been smaller. Before some more years, size should have been further smaller, which means at one point it should have been infinitely small. It should have been infinitely small. So now that is what he called as Big Bang theory. Actually, he called it as a primordial atom. Okay. So then this gentleman called Hubble, he did not know that Lemaitre published this actually in Belgian language in their own journal. So Hubble was doing independently his own marking of galaxies. He was not bothered about this. He was marking about the galaxies which he can observe. What is the distance of that galaxies from here? He was observing. So when he was observing which all stars and which all planets belong to one galaxy, he was looking at the intensity of light which you are seeing here, and he had some kind of a calculation on some visible kind of galaxies which we already know the distance from us. So based on that, he calculated an equation kind of stuff that if so much is the intensity of light which we get, then so much could be the distance of that galaxy from us. So he had done some painstaking calculations and experiment. So based on that, he started marking the distance of those galaxies from here, from when we look from our galaxy, which is Milky Way, our galaxy is Milky Way. So then it is Hubble who found out that there are so many galaxies around us. So when he started observing that light, he realized that the light from those galaxies are following a particular pattern, that each time after some time he observes, it is slowly drifting to the red side of the VIBGYOR. VIBGYOR, you see, it is coming from red, orange, violet, and in the other side it is violet. So in science, if light from an object, when you constantly measure, if it is going to the red side, that means it is going away from us. If it is coming to the bluer side, because it is coming closer to us. We will tell the science of it. I will answer the questions bit later, otherwise I will lose the flow of this. Okay, so now, so this is when you type Big Bang theory in Google, this is what actually you will see. That is an unfortunate thing. Actually, you write Big Bang theory science. So this was a sitcom in US. So I think it's a very famous sitcom. So if you just type Google Big Bang theory, this is what you get. So don't think these are Lemaitres and Hubbles and Friedmans and Einsteins. It's nothing to do with this. These are some serial stars. Okay. The actual Big Bang, you have to type Big Bang theory, science, if you take, you will get this picture. But this picture is only a visualization. Okay, so there are, in science, there are a lot of artists who work in science. So in that itself, there are special artists who work only on dinosaurs. There are special artists who only work on subatomic particles. They are artists. Their job is to put a visualization. So whatever you see as dinosaur, the picture and all, are actually artists are drawing, but based on robust scientific data. Okay, so if you're an artist and if you know science, you have better job opportunities. Okay, so these are good visualizations so that for you to get an idea. Now, don't think this is exactly how it looks like. This is for you to get some idea that at one point the universe was infinitely small, which means we have also learned that the whole matter and whole energy of the universe is constant. So that doesn't go anywhere, which means the entire matter and entire energy of the universe is in one point, which is what they call a singularity. Okay, so at that point, say, it started expanding, but this is only one theory. There are many other theories. There are the theory which was the name of our camp called Multiverse. So that theory says that like this, there are many universes. And there is another theory which tells that it's steady state, which means the universe was like this only throughout, but it is expanding and contracting, but it never goes to singularity. There are many more theories, but this is one theory which is very robust. So then it expands. So, but when it expands, what happens? It is approximately, they compare it with like a balloon. So when this expands, what happens? Distance between two galaxies, assume this is one galaxy, this is one galaxy, they separate more. And then in the structure, there is no center. Anywhere you go, it is a center. From here, it is center. From here, it is center. From here, it is center. Actually, Friedman's hypothesis seems to be very true. So the distance between all galaxies, everyone's distance between all planets, all stars, all galaxies is continuously increasing. All are stretching each other. So that is the concept of universe which we have as of now. Okay. So now this is what the proposition of Lemaitre. Now, what is the finding out of redshift? What this Hubble observed? Let us find out. I will pause after some point and take questions. Why I don't take questions now is that if I take questions, this flow will be stopped. Okay, right. So now I don't expect you to understand everything of it. That also let me tell. I expect you to understand some terminologies and the overall story of the movie, so that when you read this tomorrow somewhere, you feel this is something which you can grasp. Or these terminologies, when tomorrow somebody tells about space-time or general relativity, you feel like, yeah, we have an approximate idea. So that is the intention. It is not that you will understand all these things 100%. Okay. So now let us assume an ambulance. Assume there's an ambulance. So this ambulance, see this person and this person, the distance of this person and this person from the ambulance is same. But ambulance is going in this direction. It is having a siren. Who will hear louder voice? A or B? A or B? This is an exact center.
B.
Yeah, okay. Why?
Because the ambulance is moving towards.
So what happens? It is exactly at center. It's exactly at center.
So because the person is moving towards the ambulance?
No, persons are standing idle. Okay. So now, there you understand there is a theory. There is a theory there. There is a bit of a science there. Just try to understand that. I'll explain that. So now, you see, look at light. Look at light from the same point of view. Assume that this is a galaxy. Assume like this galaxy compared with this ambulance. Assume one person is standing here and one person is standing here. Okay, so this is Vinayak. Okay, this is Vinayak and this is Avinash. Now, if this galaxy is moving towards Avinash, if galaxy is moving towards Avinash, what will happen is, see, the light which is coming, assuming it is a wave, assuming this light is a wave, the last wave of this galaxy, from this galaxy, it will reach Vinayak bit late because this is moving. So it is continuously emitting this light, but that last light, it will stretch a bit because this is going in this direction. So if you take 1 second, he will receive less number of waves compared to him, though if this is at the center, even if this is at the center, because this is moving straight, you see, this guy will receive more number of waves because this is moving closer. Just think this wave is like a stretch, as a rock. When you are moving to the front, automatically it will stretch like this, and here this will stretch, in the opposite direction. So he will get less number of waves compared to him. Are you able to visualize that?
Yes, sir.
Same here also. Sound travels as waves, but as it is going to the front, if you see that last wave will get bit stretched here, and the next one also. So if you take in 1 second, how many waves reach here, how many waves reach him, he will get bit more of a wave. Avinash will get more waves compared to Vinayak. Yeah. So that is not just because of the distance, that is because this thing is moving. Now, when this is moving, what happens is, why you see something as blue? What is the importance of blue light? Why blue light is blue and red light is red?
Because when light reflects on,
Okay.
when the light reflects on a blue object, the all the other colors will be cancelled.
That I agree. That I agree. But what is the difference between blue light and red light?
Sir, the density of blue light is less as compared.
Yeah, density. I hope what you meant is frequency, right?
It travels.
Yeah. What you meant would have been frequency, means number of waves per second. That is frequency. Okay. So the difference between red light and blue light is how many number of waves will be there in 1 second, or in other way, how long is this wave. It is like, assume you are standing in a toll booth, you are going in a car. Okay, so let us take Elisa is going in a car. So toll booth has a car line, she stands in front of her, there are X number of cars. Okay, Ritish is going in the next booth, he is driving a truck. In that line only trucks are there. So in front of Ritish, so many trucks are there. Okay, so let us assume Elisa and Ritish are standing at the same point. Elisa and Ritish are standing at the same point. The number of trucks in front of Ritish will be more, or number of cars in front of Elisa will be more. You have a toll booth. Elisa is in a car, Ritish is in a truck. Both are at same distance from the toll booth. In front of Elisa only cars are there. In front of Ritish only trucks are there. Number of vehicles will be more in Ritish's line or Elisa's line.
The car line.
Why?
Because the car's length is lesser.
Obviously, it's a very simple common sense that if the length is less, you can have more number of that, right? If it is a scooter, in the scooter line, you can have more number of scooters, right?
Sir, is it the way the light reaches in the earth during horizon and on that blue sky?
We will come to that. We will come to that. Let us first dissect this light color itself. Okay. So now assume this red is the truck light. Assume this blue is the car light. Not that much difference in the length, but the red wave is lengthy. Okay, blue wave is shorter compared to red. So when you tell Vigio from red to blue, these colors are different because the length of the wave means from here to from here or from here to from here, is reducing. So orange is lesser than red, green is lesser than red. So it continuously reduces, and blue is further less. Okay, so what we call as a color of the light is actually nothing but depending on the length of this wave, which we call as wavelength. Then we also realize if wavelength is more, the number of waves in a distance or in a time is lesser, right? So red wave will be like a truck line. In 1 second, how many red waves will be there will be lesser compared to the blue wave, because blue wave's length is less. Do you understand that concept? This is very important.
Yes, sir.
This is very important in science. Okay, so the concept of light itself is that different colors, when you tell there are different colors, that means the wavelength and frequency means how many waves are there in 1 second. So when now we told if this galaxy is moving in this direction away from Vinayak towards Avinash, what happens? Avinash is getting more number of waves, which means he will see the light as bluish towards blue. But for Vinayak, he is getting less number of waves. That means the frequency of light which he will see is lesser. So that means the color which he will see will go to the red side. It is not like he will see full red, he will see full blue. Okay, in the spectrum it moves to the red side, moves to the blue side. Now when Hubble was observing the galaxy, each year he observes, he is seeing the light is drifting to the red side. That means this galaxy is going away from Earth. So Hubble proved what Friedman proposed and what Lemaitre put as a law. So Hubble proved that the galaxies are going away from us. He also measured the distance of these galaxies, and he also proved that the speed at which the galaxies is going is more if the galaxy is away from us. So the farther the galaxy from us, the faster it is receding away. So that is what we call as Hubble-Lemaitre law. So they have an equation also for that. You to understand, these are not just science statements. When we tell relativity, special relativity or general relativity, these are backed by some mathematical equations. General relativity predicts the orbits of all the planets to decimal points. So as per Newton's gravity calculation, the Mercury's orbit, we were not able to get the exact orbit. There was a minor change. But Einstein's general relativity equations predicts that to the perfect point. So these all are backed by sound mathematical equations. These are not just stories. Okay. Now same thing happens in sound also. That is why that ambulance example I have told. Have you seen any application of this? That if a vehicle is moving, if you are in the direction of the vehicle, you will hear more sound. Have you seen any application of this in everyday life? Have you?
Sir, birds too. Birds make sound.
Okay. See, have you seen something called interceptor? Interceptor. the police, if you are having a very straight road sometimes, you will go very fast. And then at one point, the police vehicle will be standing there and will show you hand. You won't see that police vehicle from the distance because it is very far. But when you reach near them, they will give you a ticket by telling you are traveling at 160 km/h. I also used to wonder initially how they know it. Actually, they know it with this technology. So this is called Doppler effect. Doppler effect. So what they do is this interceptor in that vehicle, they have an interceptor, it sends a sound wave. It comes and hits our car and it goes back. Depending on the speed of this car, the time in which that signal comes back to that police vehicle, it can calculate the speed of this car. So we will not see that police because it is so far. So we will drive with music, la la la, we will drive. When we reach closer only, we will realize they are there. But that time we will try to slow down, but they have already measured your speed. Next time, if you get a ticket, look at that. Okay? If you drive fast, you get a ticket, you tell, okay, ticket, we will talk later. First tell me the science behind this. Yeah? So you will get another 1,000 rupees. Right? Okay. So I will take questions later. I will move a bit more further on this. Now, we have to understand something called light. What is light? Okay. So, can somebody tell how light is getting produced?
New photons?
Okay. How photons get produced? When photons get produced? You are right. You are right. When photons get produced. So I am not seeing, I can see hardly 2 or 3 people. Okay. I want to see everyone's video. Okay, that's why I repeatedly request everyone. See, without seeing the face of students, it's very difficult to take classes, especially complex things like this. You don't get a feel of whether you are getting it or not. Okay. Can you tell how light gets produced? So the heat, brilliant. Okay. So that is the point. What Elisa has mentioned. See, when you now listen carefully. Okay, this is a very important part of science. Very important part. See, when you have heat or temperature, let us assume we are heating water. When you increase the temperature, what happens to the water?
Will start boiling.
Okay, why it starts boiling?
It starts boiling because the particles in the water moves faster. They move faster.
Particles of the water
They move faster.
moves faster. See, particles move faster when you increase temperature. If you have to move faster, what did we learn? If something speed or acceleration increase means what would have happened? You have to apply force like Rishikesh, right? That means you need energy to apply force, right? So where from that energy came? When you increase the temperature. So understand that energy and temperature has a very intrinsic relationship. When the temperature increases, the energy increases. That is why the particles, you can see when you heat water, the particles will start moving faster. Right? Have you seen that? It starts moving faster. Right? So when the temperature of a system increases, the energy will be high. When the energy is high, movement will be more. When movement is more, particles will start getting hit each other. They will become hot. You already give it temperature. Because of that, energy is there. When you have high energy, it increases the temperature. When you have high temperature, it increases the energy level. Okay. Now, when the temperature is very high, because of this high energy, because of this particle collision, it will emit something called photons. That is what we call as electromagnetic radiation. It is the property of every object. If I put makeup into this kettle and heat her up, she will start emitting radiation. Okay? Before that, she will cry so much that we have to switch off the stove. That's another matter. But otherwise, if she permits, every body which has a temperature will have a radiation, but it is less at lower temperatures. The higher the temperature is, the radiation is more. That is happening because of this particle called photon. Okay, so that radiation is what we call as electromagnetic radiation. Why? It has the property of magnetism also. It has the property of electricity also. It is because both are coming from the same guy. It is what Maxwell found out, that both are same because both are coming from the same particle. Now, what we call as light, is a small part of this radiation. So this, whatever you see in the screen, is this electromagnetic spectrum. I will tell again, listen carefully. If the temperature of any object, when it increases, its energy will increase. Reverse is also true. When the energy increases, if the volume does not change, then the temperature will also increase. Now, when the energy increases because of high temperature, the particles will start interact more. Okay, that is why when you increase the temperature of a solid, it becomes liquid, and further when you increase, it becomes gas. It is because they have more energy, they have more space, they hit more each other. So then, of this temperature, any body with a temperature has a property that it will emit radiation. In science, we call it as black body radiation. Okay, that radiation is produced by a particle called photon, which is what we call as electromagnetic radiation. So this is the radiation which comes, and light, what we call as light, is only a small part of this electromagnetic radiation. Whether it is sun, whether it is the matchbox which you have, whether it is a small fire which you lit, everything produces same electromagnetic spectrum, but in varied quantity. Okay, so when you tell that there is something called light is coming, actually what you are seeing is an electromagnetic radiation coming, in that only this part is visible. That is what we have made it bigger here. Okay, in this whole spectrum, this we have made it bigger here. So what is the difference between all these things? So in this electromagnetic spectrum, it is consisting of so many waves of different wavelength. Remember, we told the length of the wave is different. Now, when length of the wave is different, like that truck and scooter example we told, if wavelength is more, frequency is less. So, which is the highest wavelength? That is what we call as radio. We use it for radio communication because it has to travel for more distance. Mountains and big objects, it has to jump and go. So, its wavelength is very high. Then there is microwave, infrared, and then there are things, there are spectrum for which the wavelength is very less, X-ray and all. Where do we use this? X-ray, gamma ray and all. Where do we use this? Yes, we use it for treatment. Why do we use X-ray? Why do we use X-ray for taking what you call as taking X-ray? Why do we use X-ray? Why are we not using radio wave?
It penetrates to our screen.
Yeah, because it penetrates, because You see, its wavelength is less. So it cannot jump and go. Why we are taking an X-ray? What is the reason you take an X-ray? Body X-ray?
For checking if any bones is fractured.
Yeah, you want to see apart from flesh, you want to detect only this solid particle. So the wave which you send should stop at that. It should not jump and go. If the wavelength is very high, it will jump and go, right? Now X-ray, gamma ray and all, their wavelength is very short, so it cannot jump to the bone and go. Or if there's a foreign particle, so it will hit there. So when we take an X-ray, in all the flesh and all other part, the X-ray will pass through. But wherever there is solid, it will stop and come back. That portion we can see in the X-ray, right? So that is electromagnetic spectrum. This is the property of any body with a temperature. In that, what we see is the visible light spectrum. What distinguishes different parts of this electromagnetic spectrum is the wavelength of each of this ray. When the wavelength is less, number of waves per second is more, that means frequency is high. This is why I asked you that question of blue in the daytime of the sky and horizon in the evening time becoming red and all, to bring you to this point that it is wavelength that matters because of wavelength frequency also. Okay, so this is the property of every light, whether light coming from sun or any other star or from any other light source, whatever you get from your candle, it is the same property. Okay, now moving on. See, this I hope you understand. So when we tell, Avinash explained that before, when we tell that we see somebody, see what is Ayati's dress color?
Blue.
Blue. Why it is blue? Why do you think it is blue? Why you look, when you look at it, why you feel it is blue? Yeah, like Rishikesh mentioned, it reflects blue. So Ayati's dress is made of a material which absorbs from this visual all other wavelengths, all other frequency except blue. The blue wavelength it emits, everything else it absorbs. So you feel it is blue. Yeah. So why is Megha's dress seen as black? Don't tell that she bought black dress, that's why, okay? Tell from this point of view. Why? Why you feel her dress is black?
Because it reflects light.
Because? Yes, repeat.
It absorbs all the light.
Yeah, it absorbs all light. You can't see any light. You see nothing. And so why Elisa is seeing as white? Because she absorbs everything. So when you tell that this is the color of something, that only says that specific wavelength or frequency is reflected. Right? Okay. Now, I'll just complete this part also and then we will get into question and answer. I'm not spending much time on fundamental forces. I hope there are other courses in Greynet which covers this, right? I hope all of you know the 4 fundamental forces. If not, there are other courses which cover this. Can somebody tell the 4 fundamental forces? Unmute and talk.
Weak force, strong force, electromagnetic force, and gravitational force.
Exactly. So we told the universe is built of matter and force. Matter is like all the atoms and everything, whatever we have, the wood in front of the computer, you and me and everybody is made up of matter. Yeah, and yeah, Rishikesh is in a presentation on this. Now forces, there are 4 forces. As of now, you think it is 4 forces. Okay. Now, which are those 4? One, obviously gravity. because the gravitational force is that is why this we told the sun and moon and earth and this arrangement is there because of gravitational force. There should be some force working. So that's what we call as gravitational force. Then inside the nucleus, all protons are sitting. How can they sit in the nucleus? Because protons are of same charge. You know, same charge should repel. Is it not? Same charge should repel. It is like in your classroom. If the teacher is not there, your energy will go up. You will fight each other. Blood will come. Fight will come. So teacher comes with the strong nuclear force, so that everyone, Ailisa, Mega, sits as if they are very good students listening to the class. Okay. So that is what this strong nuclear force does. All these protons sit like good boys without fighting each other. Okay. Now, when it comes to electrons now have to rotate your nucleus. You have to hold that electrons there. So for that, you need another force, that is electromagnetic force, which is now what we realize. Whatever we learned as the electromagnetic radiation, this is responsible for that. Then there is another thing called weak force, which is actually the nuclear decay. Nuclear decay, whatever we call carbon dating and all those things happening because of that. Okay. So I'm not going to spend time on this because there are other courses which deal with this. So we call these by some names. The strong nuclear force name we call it as gluon, electromagnetic photon, weak nuclear called boson. Gravitational force particle we have now never been successful to find it out in the experiments. Why you do know? Why you know what is the challenge in finding out gravitational force particle? Do you know what is the challenge? So all others are detected. Gravity, we believe there is a particle, okay, which somebody calls graviton, but never been successful to detect it in particle accelerators. Any idea why? Anyone? That is because of the big G. You remember the gravitational equation, the G, gravitational constant. That is some 10 raised to minus something, right? So it is so very small. So gravitational force is a very small force. That's why yours and my gravitational force we can measure. Only we are able to see gravitational force of stars and planets and all. So in particle accelerator, we are dealing with shorter, motor atoms. So their gravitational force is so feeble. It's very difficult to measure. Extremely difficult to measure. And now we are not even sure whether it's there. Okay. Now these are this is the subatomic structure. I would always urge you to attend a course on this by a gentleman who works in this setup called Rohin Narayan. So that is coming after 2-3 weeks, called Particle Zoo. So he will give you the data from his particle experiments he will has made some programs, software programs. So you can play around with the real test data of this LHC, okay? Real test data of this collider. And I think you can get some idea about this structure. So this is what is called as particle soup. So this, as of now, our understanding is that inside an atom, these many players are there. That is our understanding as of now. Okay, I don't want to get into the detail of it. Only thing that there is matter and force. These are force, the four things which we told: gravitational, electromagnetic, weak, all those things. Sorry, not gravitational, strong nuclear force. And there is another brother called Higgs boson. Forget about it. And these are the matter side. Okay. So we call this matter side as fermions, and this is called bosons. These bosons actually are called after an Indian scientist called Bose, Satendra Bose. And this is after a scientist called Fermi. Okay, so, but the details of this, there are other courses which take care of it. Now, I would open to all your questions.